Section 6.3.21. An army monitored 10 cavalry corps for 20 years and recorded the number of X of annual fatalities due to horse kicks for the 200 observations. The accompanying table shows the data, and we want to complete parts A through D. Now the first thing is we want to compute the proportion of years in which there were 0 deaths, 1 death, 2 deaths, 3 deaths, and 4 deaths, and we're going to complete the table that they have here. So we have the number of deaths, and then we have the proportion of years. So let's go ahead and do that. So here we have our table, so we're going to open this up into StatCrunch. Okay, now once we open this up into StatCrunch, we know that there are 200 observations. So what we want to do is we're going to take this second column, which is the number of times that are recorded for each number of deaths. So for 0 we have 109, for 1 we have 64, and so on. And we're going to divide each one of these values in a second column by 200. So in order to do that, we're going to go to Data, and then we're going to compute, and then we're going to go ahead and compute an expression. So we're going to go ahead and build this expression by taking the second column. So we're going to take parentheses and then the second column, okay? And then we're going to close the parentheses. We're going to take each individual value in there, and then we're going to hit divide. So we're going to divide that by the number of observations, which is 200. We're going to select OK, and then select compute. And therefore, now we have our values. So now let's go ahead and call this the proportion of years column. So therefore, for 0, we should get 0.545. For 1, we get 0.32. For 2, we get 0.105. And then for 4, we get 0.01. Okay, so therefore there is our table that we completed below. And now from the data in the table, we want to find out what was the mean number of deaths per year. So in order to find the mean, okay, we need to find the expected mean by taking the first column, which is the number of deaths, and multiplying it by the proportion of years. So now we're going to create a new column. Okay, so we're going to go Data, and then we're going to go ahead and then select Compute and then Expression. We're going to go ahead and build that. So again, we're going to take the first column, so left parenthesis, select the first column, and then close the parenthesis, and then we're going to select multiplication, and we're going to multiply it by the proportion of years. So left parenthesis, locate the proportion of years, and then close the parenthesis, select OK, and then select Compute. Okay, now this is the last column that we created. Now in order to find the mean or the expected mean, we need to add up all these values in this column. And by doing so, we're going to go to Stat, Summary Stats, and go to Column. Okay, and then again, we're going to pick the last column that we created, which is that one. And then we're going to scroll down here, and we want to find the sum of that column. So we're going to select Sum, and then Compute. And therefore, we get the value of 0.63. And that's going to represent the mean. So therefore, that is the mean. So if we take a look next here, the mean of the number of deaths per year when we add up that column gives us 0.63. Okay, now we're going to use this mean that we got in Part B, okay, for the number of deaths per year that's found in this part, and the Poisson Probability law to determine the theoretical proportion of years that 0 deaths should occur. And then we're going to repeat this for 1, 2, 3, and 4. And so by doing so, we're now going to open up a new column, okay, and we're going to call this P of X because we're doing the Poisson probability for P of X. And so what we're going to do is, again, we're using the mean of 0.63. So we're going to go to Stat, and then we're going to go to Calculators, and then select Poisson. Okay, and I'm going to expand this a little bit so that we can go ahead and then put in our probability. So for the Poisson calculator, our mean that we found in part B is 0.63. And then we're going to generate each value for the number of deaths for each value of 0, 1, 2, and 3. So for when x is equal to 0, okay, we're going to compute the probability. And so this is we're going to round this to 4 decimal places. So we get 0.5326. So let me go ahead and copy that again. So we should get 0.5326. Okay, and then we want to find exactly 1. We're going to select 1 and then select compute. And then this gives us 0.3355. And then exactly 2, we're going to compute that, and that's going to be 0.1057 rounded to 4 decimal places. So that's 0.1057. And then we're going to put in exactly 3, and that's going to give us, rounded to 4 decimal places, 0.0222. So we're going to copy and paste in here, so 0.0222. And then when it's in exactly 4, we're going to compute and then round that to 4 decimal places. Is going to give us 0.0035. Okay, so now let's take a look at our table here. Okay, let me go ahead and scroll that down a little bit here to make sure that we have our right results. And so therefore we have 0.5326, 0.3355, 0.1057, 0.0222, and then 0.035. Okay, now the next question says we want to compare the observed proportions. Okay, that is from this step, part A, and we're going to compare it to the theoretical proportions. And we want to say, do we think the data can be modeled by the Poisson probability law? Well, basically, since we can possibly view both of these together, let me go ahead and take a look over here on this screen. Okay, here is the proportion. We can see that 0.0545 is similar to 0.5326, so that's kind of comparable. We have 0.32 to 0.3355. Those two are comparable. 0.105 to 0.1057, 0.02 to 0.02, 0.01 to 0.0035. Therefore, we can say that the observed proportions and theoretical proportions have close values. So therefore, the data can be modeled by the Poisson probability law.